Welcome to Hancock College, reminding you guys that all disciplines are important. Doesn't matter whether it's accounting all the way to welding. Our community colleges offer all of those disciplines, and everybody has their advantages and disadvantages, and so we want to try to expose and show the people here some of our wonderful facilities at Hancock College. So hopefully you're enjoying some of the demonstrations inside the rooms being presented from the students, as well as our chemistry demonstrations up here as well. My name is Dustin Nury. I teach chemistry here in the Life and Physical Sciences department. And here is our wonderful professor, Danae Madrid, who also teaches chemistry here.
Welcome! Thank you for coming. As Dustin said, my name's Professor Madrid. I teach chemistry here at Hancock College, and I want to introduce you to some of my counterparts here. I have Sean Gottlieb to my left. He also teaches chemistry here. And I have who I thought was Steve O'Neill, but maybe he's Woody from Toy Story or Life Size. I don't know. He'll introduce himself.
It's Sybil. Just call me Sybil.
Sybil. Okay, that's Sybil to my right. And then I have Sean's lovely wife, Kelly Gottlieb from Cuesta College. Don't hold it against her. Who is here to help us demonstrate some chemistry tonight. And without further ado, I'm going to hand it off to Kelly.
Thank you. Hi, everybody. So happy to be here today to talk to you about chemistry. So chemistry is the study of matter, and despite what you might think, matter really matters. Matter is basically everything. It's got mass and it's got volume, which means there's a weight to it and it takes up space. Now there's a lot of matter. I mean, if you look around you, there's a ton of matter around us. So we needed a way to classify that matter. And so we decided on 3 different classifications: solid, liquid, and gas. Can you guys tell me what state of matter this is? Just shout it out. Solid, right. So solids, they keep their shape. I can kind of move it around and it's still staying in that solid shape here. It's definitely got a lot of mass to it, and actually we can't see because they're really small, but those little molecules making up this solid are in very organized shapes. And when we drop it, it still stays solid. It didn't turn into anything else.
And then I have our second state of matter, which would be what again? Liquid. And I have this bumbling gentleman over here showing you something different about liquid as compared or contrasted to solid. Instead of holding its shape, this obviously doesn't. Liquid holds its volume but does not hold its shape very well. So someone like Sean, maybe he shouldn't be your waiter, okay? Because he's going to spill on you. So he's going to show how I can use this liquid and that solid and go into our third phase, which is gas. So let's see what's different about gas. So what's different is that it doesn't hold its what? Shape, right? It fills any container, or if it's not in a container, it just goes crazy. So we're going to use these 3 states of matter tonight, and we're going to convert from one to the other and see what fun things we can see from these demonstrations. And I think Sybil, are you up next? Okay, I'm going to turn it over to Sybil.
So, I've been given a task to transmorph these materials from what they are to what they really didn't want to be all their life. I mean, these solids, that thing came from a tree. It's nice and cellulose, and that's a cotton plant, and that came from a pharmaceutical company. But if I'm going to transform these things, can I have something to melt them with? Can I have something to boil them with? Then I'm going to tear those suckers apart into tinier molecules that'll float away into a gas. Fine. But in order to do so, I'd like to know a little bit about these molecules. When you have most atoms and molecules bumping in the night against some other atom or molecule, sometime it's out there searching, I just want a few more electrons from that atom. And it'll go over, there's so many atoms and molecules that are electron takers, we call them oxidizers. When a piece of iron gets oxidized, it gets its electrons pulled off that were the furthest out, way out there in the tules all by themselves, and you went and ripped them off, you meanie oxidizer. but it takes the electrons. Oxygen is one of the best elements for taking electrons in the whole periodic table. But when you do it to iron, it becomes rust, and when you do it to silver, they call it tarnish. When you oxidize and rip off electrons off of a stain, you said I bleached it. When you rip electrons off of that bacteria, you said I disinfected it. When you change that sugar into alcohol, you say, oh, cool. But when it goes to vinegar, it says, oh, never mind. Who needs that much Italian dressing? But these molecules I'm going to transmorph. No, they're already transmorphed, because this cellulose was contented to hold onto its neighboring atom. It was contented to hold on to its neighboring atom for as long as that tree was still kicking, and it's still holding on to that neighboring atom, and it just won't let go. Some atoms hold on to the neighboring atoms. I still have soot in there. I'm going to try it again. I can transmorph that molecule solid into another one. I can take off a few atoms and put on a nitro group. This thing is now nitrocellulose. Hollywood called it celluloid film. Other people call it the stuff that ping pong balls are made up of. It is not stable. I don't have to heat it up to 451 Fahrenheit. They didn't write a book about burning this stuff. This cotton doesn't burn worth a darn. Really? Doesn't burn worth a darn? That's been transmorphed. I'm not going to experiment anymore. Cotton doesn't do that. This thing is nitro cotton. That's the cotton that was used to send artillery shells from one battleship to another. That's the stuff that was used to blow rock walls off of that mine. That is not nice stuff when it's combined. It is not exactly cotton anymore. This stuff is an acne medication that normally normally comes at only 2.5%, but it has an oxidizer on one end that rips off electrons, and it has a fuel on the other end. This has a nitro oxidizer on one part of the molecule and the cotton on another. It has a cellulose and the nitro. What better combination to put oxidizer and fuel in the same container? So have at it, dude. Go for it. Oh, is that all there is? Oh, I'm real disappointed. That's very unimpressive. Can't you do anything else? Oh, come on, it's boring. Cool, I like that. That's cool. Okay.
We have another similar demonstration to that, where we're now going to turn a solid into gas. So back in the 1850s, people would work in their homes and actually try to mix chemicals together. And Frederick Schombein in Switzerland was trying to make some explosives, and he accidentally spilled some acid mixture, and he used his wife's cotton apron to wipe it up. Laying it on the stove to dry, eventually it just disappeared. He heard a boom, and he eventually named it Scheissbomball, which means gun cotton. So now we've got 4 pieces of that gun cotton kind of laid out about the size of her cotton apron after it had been reacting with those acids he had mixed. Let's watch a solid going directly to a gas.
This is gun cotton on steroids, isn't it? Cool. Can I see that again?
Her apron was gone in a flash. Our next demonstration is known as the popular thermite reaction. This reaction reacts at 2,500 degrees Celsius. We actually have some solid inside these clay pots here, which Professor O'Neill will discuss in just a little bit. And what we're going to see is that solid inside there pouring out as liquid molten iron.
So we have railroad spikes that normally are pounded into the railroad tie, and we have a rail that somebody's turned into a homemade anvil. But there were times when they would weld these things together with the molten iron coming out of that. They'd shape charge it down here with the thermite, and not up in here, but down in there, and it would make so much molten iron and fuse one rail to another rail. I still see that being done today I saw it the other day on a television show called Railroad Alaska. Now he has iron rust in there. He has iron rust that's been oxidized about as much as it normally happens. But when iron loses its electrons and it gets I'm standing back. When iron loses its electrons, and it like gets an attitude. It's called an ion. It's an ion with an attitude. It wants electrons back, and we put one of the best losers in there, aluminum. Aluminum says, hey, take my electrons, please. Iron says, thank you very much. And that's molten iron returned from the ashes of the rust.
That's some hot stuff right there. That's all I gotta say. So now Sean, Kelly, and I are going to show you a liquid to a gas. And because this happens so quickly, this flammable liquid will be ignited and you'll hear a whoosh. And see if you can see what color it exhibits once we light them. We'll try to do it synchronized, but sometimes we're not so great at that.
The color coming off is from boron. You can get the same color from boron in 20 meal-team Braxo on the fire.
All right, you guys ready? Okay, let's count down. 3, 2, 1.
Cool.
Whoosh, 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 whoosh.
Okay. Thank you. Make sure. So what I'm going to do is try to burn some natural gas that you have coming into your home if you live in town. This is methane. It's one of the gases that people are starting to learn that it's something that ought to be worried about getting into our atmosphere, because it causes about 8 times the effect of global warming as the other compounds that they normally talk about. And there are large, awfully large reservoirs of frozen methane underneath the ocean and frozen methane in the Arctic. And if that tundra were to melt, they're concerned that you'd have a bit of a problem in your day. I'm going to show you the thing about methane, though. It's one of the few gases that's less dense than air. And so this thing, like a hydrogen balloon or like a helium balloon, should float. And that's that. There's only a handful of gases on Earth that are less dense than air. Hydrogen and helium, neon, very, very few gases, ammonia, but very few. And okay, I'm gonna have to make some bubbles differently and show you how less dense they are. Let's try this one. Okay, here we go. So these bubbles are, even with the weight of the water and the soap that's on it, even with all that weight, these bubbles are naturally buoyant. They're floating up. Inside the house, you can get them going about, I'd say about 6 feet, 7 feet tall. It'll go straight on up. Let go of me. Can't you go up any higher? Yeah, I want you to go up higher. Good, Bubble. Look at all the people now. Don't be shy. I'll hold you, you poor little Bubble. I'll protect you from those people. Whoops. I'm sorry, Bubble.
You can make another bubble. You killed him. You killed him.
I think I better try that again. The burner was on. Silly. I bet you if I do that a whole bunch of times, it'll keep burning. But it doesn't burn very well. The carbon molecule is breaking up, and not all the carbon is going to gas like the other ones did, go totally into gas. This one's going into glowing carbon. The carbon is not totally burned, not carbon dioxide, it's just carbon glowing incandescently like an old Thomas Edison light might be. An incandescent light bulb. It'll deposit as soot all over the fireplace and soot over an old kerosene lantern. This thing is pathetic for trying to get gas mileage. I understand they're going to try to make some cars that are running on methane. Well, I hope they get a better air-fuel ratio, because this isn't going to get you anywhere. Did you hear the loud noise? No. Why? Because it's not exactly like a Harley Davidson here without a muffler. It's like Wilbur Milk Toast. It does no power in it. You got to have an air-fuel ratio. Can I have an air-fuel ratio? This is about the same size as that small bubble I had. That small bubble I had was about this big. And this is only 25% methane. All the rest of it is oxygen. This is an ideal stoichiometric, an auto mechanic calls it. I mean, they have an oxygen sensor, a map sensor, and a computer to make sure you get the best mileage. You take off that muffler and you know you're getting power. Oh, you've seen this before. What did you say? What? I couldn't hear you. Okay, that's a good air-fuel ratio.